Easy.
You're welcome. I will take over the control of screen if you don't mind.
Yeah, I think we can get started now, so that's fine.
Okay.
Anton, if possible, 1 minute, Maya. Can you go to the next slide?
Yep.
So guys, to prepare this presentation, actually we involved 6 people at least. First, I would like to thank to Anton that sick last day get temperature but join us. And Ivan, who joined yesterday to replace Anton and prepare the demo. And Victor for presentation design. Guy, Vlad for advising. Yeah, and now let's start the presentation.
So, in general, we wanted to tell you a short story about how testflow.py operates, how tests are done, what tests are covered, and also shows what we have reached so far with board farm, which is one of the possible ways to reach the hardware testing, which is not done yet. So to keep everyone on the same page, let's define some terms. MCU, which you will see everywhere, is just a controller, just another name. MIUT is an agent, just to keep everyone on the same page so everyone understands what we are talking about. So what we have right now is testflow.py. Why it was created in the first place? Initially, it was because certification tests, which are done in Testbed, are taking a lot of time. Basically, it's around 2 or 3 hours. Using it for everyday testing when you're developing is not very convenient. So need in some of kind of equivalent was raised. Basic goals behind it was to provide a fast and confident alternative to the official testbed, which can be used for developer purposes. It's able to work in so-called dummy mode when we are testing controlling agent in Dockers. Basically, it's called dummy because we don't have any real hardware connected, so that's why it's dummy. And more than that, it's maybe tuned to whatever we need for developer purposes. By whatever we need, I mean, for example, speed up, run some additional checks which are not part of the testbed or official certification, etc. Existing testflows.py, this is actually a file which is a test by itself. Its flow is quite simple. Basically, it spawns 3 Dockers, one for MCU, so called controller, and for 2 agents, repeater 1 and repeater 2, as certification scenarios often use 2 of them. Gets all max from devices. It's required to format KP commands which are sent to controller in order to control whole shim. By shim, I mean controller, agents, setting up network, because you have to get some connectivity between Docker containers. They are not tied up initially. So you have to set up a network, connect the repeaters to the gateways, etc. And do requested test. Basically, right now, there is plenty of them. There is no yet official mapping to the between tests which are available right now and tests which are defined by official documentation, official certification tests. But list is here. basically this is all tests which we have right now. Test topology is kind of strange. Seems like it's not finished. It's not a finished test, but Arnout may comment more on it as he was doing the transition from testflow.sh from shell script to the Python script. And like one of the parts of the presentation, what is important part is we are having a lot of issues right now with degradation, which were noticed recently by Tomer especially. We are having some issues with degradation. What I mean that even if testflows.py are used in our daily CI, we still see that some tests which were fine before commit are failing in testbed. And right now, as part of regular development tests, we have to run the sum certification test, which is relevant to changes you do as part of your regular CI, part of regular pull request. So in order to easy that work and to provide some mapping between tests which we have and tests which certification basically defines, we have to do some mapping. This mapping is actually some work in progress because no one has done it before. So currently there is no official document which everyone agree upon, which will state how we map the tests in test.flow.py with certification tests. What you see behind your eyes is basically correspondence.
On Tuesday, we'll have our shit out of the way.
Also, this info is published in 920 pull requests, so everyone can comment or check.
He said, missing everything.
Guys, can please everyone check if you're on mute? Thank you. So this is mapping between agent tests and testflow.py tests. Whatever you see in parentheses is not for sure right now because it's a lot of work to be done. And once again, there is pull request 920, which you can check. We have there published a result of analysis of testflow.py, which have a definition, some pseudocode definitions of tests, which KP commands are sent, what logs are checked, and etc. You may check that and do any corrections which you think are right to do. The second slide is basically the same mapping, but done for controller tests. Once again, the same info is shared in pull requests, so you may check it much more viewable there. Some tests, as you know, testflow.py, because of its specific, sometimes we are one of the part of speeding up. One of the benefits of having testflow.py is speed up of the whole process. This is done by testing multiple official test scenarios in one single testflows.py test scenario. It sounds kind of weird from the beginning, but it's logical, as by logical unification of those tests, we may actually speed up the whole process, because there is no point doing, for example, 7 MCUT test scenario 7.1, 7.2 without doing the same scenario for agent, which we actually do. So for test.py, so that's why some testflows.py scenarios are mapped to a few official certification tests. Once again, take a look, please, for pull request. Any your input, any corrections are highly welcome, because it will help to get the most precise info that we can. And here comes some kind of part one. This is statistics. Basically, data was gathered by hand. By hand, I mean I said and started to counting all the tests which we have. This statistics is based on info from this slide, and plus official certification documentation. So, general, our rating is not good, actually. For mode tests, we are covering only 34% of whole scenarios. For MCUT tests, we are not covering about 42%, which is good. We have the half, not bad. In overall, we are below the half of the official certification test scenario, which basically for you as for developer, it means that you have to be very accurate when you are working with testflow.py and always check if changes which you are doing are covered by testflow.py, and if you are not sure about that, it's better to run the test in Testbed right now in current situation. Mainly, once again, statistics gathered by hand, maybe not totally accurate, but I think the mistake is in 5% range, something about that. Current challenges which we have faced with testflows.py and what has to be done to improve it. First of all, currently testflows.py is doing tests only with dummy Dockerized MCUT and MIUTs. And recently, as I have told you before, recently we see that something which works in testflows.py is not actually working in Testbed. One of the good examples which Tomer noticed was, I guess, 421, which we were able to pass in testflows.py, but it was failing in Testbed. And actually, there was a few more. I don't recall the exact names. I don't think it really matters. Currently, there is no clear mapping between testflows.py and certification tests, which is bad. By bad, I mean we have right now developers have to guess or to ask someone more experienced to check or to ask how changes which they do relate to the official documentation. I hope that everyone has someone to ask, but having such document is crucial right now, as I can see.
I have just one thing to mention about
Yes.
test flows. The reason we have the dummy implementation and we are using testflows PY is basically because at first we did a certifiable controller. Controller doesn't need Wi-Fi at all. So basically we could test everything, and we are basically testing everything with a dummy implementation because we don't need Wi-Fi for controller certification. The moment we moved to agent certification, tests are now involving real hardware, real Wi-Fi. Some commands that we used to simulate, we can't do that anymore, like selecting channels and verifying that the correct channel was selected. So this is the reason that now we are getting to the point that we need actual hardware, because agent certification is all about the hardware, about Wi-Fi. This is all I wanted to say.
Tomer, can you prove that the differences are only in the Wi-Fi area?
Yes, because the only difference between a dummy controller and dummy agent and controller and not dummy agent and controller is the abstraction layer called the BWL and BPL. BPL is less important, but BWL is basically the Xerox wireless library, which provides the abstraction over the wireless driver, wireless OSTPD, DWPAL, all of the layers that get us to the real hardware, to the Wi-Fi. In MCUT tests, we don't have Wi-Fi because controller can run without a local agent. Controller can be controller only. in agent tests, you have to have Wi-Fi, and this is why we have dummy BWL that is basically implementing all of the APIs for example, set channel or any other Wi-Fi API, which basically does nothing or just updates some parameter that later you can read and say, okay, this is now the channel, this is now the credentials, all of this. And this is the only interface that is built differently for dummy controller and the agent and non-dummy. In the non-dummy implementation, we have a real implementation of PWL, which actually calls DWPAL, OSTPD via DWPAL, and NL802.11 to the kernel. So this is something that can't be covered by the dummy implementation. This is why we need the real hardware tests.
Okay, but maybe improving the dummy library to act more like the real hardware might also help.
This will also help, but it's a matter of you anyway need to test the real hardware, and testing the real hardware is just you can do it with one device. So having a improved dummy implementation is nice, but it's not always that easy to accomplish and to simulate. And you need to come to a balance between how much you invest in dummy and how much you invest in the real implementation. So I think we're at a pretty good balance here. For dummy, we should simulate whatever we can without too much effort of simulating real hardware scenarios, because I think it's an overkill. And for everything else, this is the reason that we need the test flows PY, test flows using a real hardware test. And this was the direction from the beginning.
On the other end, I agree with you that it's a matter of balance and how much you want to invest in the dummy. But on the other end, if you're testing on the real hardware, then you have less setups by definition.
Yes, but not entirely, because the only thing that you need, because a gateway, a RAX40 device can run both a controller and an agent, you can basically run the entire test, every test, with a single device and maybe one client. So it's not that much of because every developer in the open source, we have budget. We can get RAX40s, we can get one RAX40 and nuke per developer. It's not something that is too far-fetched to receive. It's important that we have it. And in addition, we have the CI. So with a click of a button, you can run a real test with the certification. So imagine that the whole point of the test flows is for the CI. And in the CI, we surely will have RAX40s. We have them already. We have RAX40, we have a laptop, which can act as the controller. And we have GLINet that can act as a client. So exactly like I showed yesterday, that you can just trigger a specific test on your branch using the GitLab CI. You will do you can do the same for you. You will do the same when you have automated tests that run on real hardware. It will be automatic. What I did was I had to find some official test that provides enough coverage to what I wanted to test, and had to run it manually. By the time we have good test flows that are running on real hardware, it will be automatic. You won't need to worry about it because the coverage will cover everything with a single test that will run for 1 minute or 2 minutes, or multiple tests that in total will run in a matter of minutes. So this is the idea, that the developer will not need to worry about it.
Okay, let's keep the questions for the end, please. Let's try to move on with the presentation as much as possible for now. Is that okay?
Sure.
Currently, to continue with this slide, currently we have a low coverage, if you have seen, of official test suite, which means that basically most of the cases, according to the what I have calculated, we are not covering. Sorry, we are not covering more than half of the official test suite. So currently, we still have to do the double check using the official testbed CI, which we have connected, as was shown yesterday. You can do that using the GitLab CI, but it's better to, as I get, we have only one testbed, so we should not keep it busy with something which is not actually not requires testing. But it's up to you. And one of the challenges which we have right now, the biggest one, I guess, is moving to the hardware testing. And this move requires refactoring of the test flow.py, because currently there is no that easy way to add an abstraction of test setup, abstraction of device and the test into that file, in the whole structure. This can be reached by two ways. Currently, there is two options. One of them is to build something on our own, some custom tests in this custom infrastructure, or there is other open source project which is called Board Farm, which was also and is evaluated by us. And basically, if there is no other questions regarding the test flows.py, we will move on to the presentation of what we have by now ready with board farm evaluation. And it's up to audience to decide. Anyone have any questions by now? Okay, I guess no. Then let's move on. Especially this part regarding board farm test setup, etc., will be covered by Vladyslav to begin. So basically, he will tell you a story about basically like what we have in the lab right now. It's it's a RAX 40, few of them actually, and Raspberry Pi jacketing. Basically, Raspberry Pi controls its consoles, serial consoles of RAX. It has some connection via switch to the RAX 40s, but let's give Vladyslav a chance to explain how it will work in terms of setup. After Vladyslav, Ivan Yefimov will take control and show you how all of that looks in real life, how tests are run, what modifications we have to do to come to the current state of some kind of proof of concept.
Why do you need you need a switch because you have only one interface in the Raspberry Pi?
Yes,
okay.
yes.
Let me explain all this part.
Okay.
So, in this slide, we can see our test setup on RLab. It consists of routers RAX 40, one Raspberry Pi 3, and switch. So, Raspberry Pi has just one Ethernet interface on hardware, and we have used virtual networks via our switch for dividing WAN and local area networks and LAN. So the main idea of this setup is start controller in the Dockers for covering two cases. First case, we have two developers. Each developer can work with own boards using separate controllers and separate Docker containers. And the second case, when we want to run tests for both or more boards using one controller in one Docker container and 2 or more routers. So in this slide, we launch board farm, which will create a Docker container with controller and will configure all network connections. So after it, board farm will send the commands to the controller, and in a separate way will check results of execution via UART serial interface for the chosen box.
Why does the board farm, written here that board farm is sending CMDU message to the controller, but I don't think it's correct. The board farm should use copy commands.
Yes, you're right.
Yes, you're right. It's copy commands.
It's typo.
So questions about setup?
First of all, it doesn't have to be a Raspberry Pi, right? It's just for convenience.
No. Anything which is able to run Python will do.
Linux.
Okay.
Linux can run Python. Yes.
Okay, and you don't necessarily need a switch if you have also USB connection, right? Because you can use USB to ETH.
Yes.
Okay.
Yes, but we are small startup. I sure that the community also works some way. Actually, this setup allows us to run many controllers on same Raspberry Pi. So if you want 2 or more developers work on this setup, every one of them can run controller and Docker. Every Docker will be on different namespace, and with switch you can route the traffic to different routers. So you can just use less equipment for many developers.
The idea behind using
sounds good.
It's just to demonstrate that Raspberry Pi is pretty simple by itself. It's easy to get. So the idea behind Raspberry Pi is that this board farm may be used even with something simple as that. So even some third parties, for example, if some newcomers will decide to join in, they will be able to build the same in their homes if they wish to take participation in the project. I know this is not the goal for prpl Foundation, but this kind of demonstration, so they can join without much efforts.
No, it's really interesting. If you have basically what it means is that we can have, for example, we can even use our development server. We can use a single NUC to control multiple RAX40s. But we are Intel, so we have many NUCs, so we don't care about that.
Yes. Dockerization for control is done just to allow a few people to work independently at the same time, just for that.
Yeah. Okay. Yeah, so it looks good.
Any other question, Vlad? Do you want to add something more?
No, I think we can start demonstration.
Okay, I will start the sharing.
Yes, you may take it.
Oof. Desktop, yes.
So basically what you will see right now, Ivan, you have shared the wrong screen actually.
Sorry, 1 minute. Desktop 2, yes. Yes. Can you see my screen?
Yes, let me get some intro
Okay.
shown. Basically what you see, this is Raspberry Pi which runs the whole test setting. Ivan, basically what Ivan is inside of Raspberry Pi, and will show you how everything works, what changes do. Ivan, take over the control and go into the shadow.
Okay, thank you. Firstly, I would like to see how board farm run exist inside board farm tests against RAX40. And then I will show the description of test setup in board farm configuration files. In below, you can see that board farm ran two additional Docker on LAN and on WAN side. That's just an example that board farm can orchestrate several Dockers, for example, or any maybe other virtualization things like Camo. On the top, you can see that board farm tests send the commands via UART of board and analyze the output. Okay, that's a number of simple tests which analyzed memory, process list, and similar things. Okay, in the end, the board farm printed that 5 tests has been passed, no failures, and the final configuration of test sub that has been used, that RAX40, the command to open UART, the type of UART connection, that is local serial, locally open at serial console, and two connected devices that on LAN side and one more on WAN side. Both are Dockers of board farm node, specially prepared Docker image with many test tools such as iperf, tstbed and netperf, and so on. So board farm can run it, and before the start, I said that concrete Docker container must be attached to Docker network, which contains virtual LAN interface mentioned by Vlad on previous slide and test up description. Another container will be attached to another network to be isolated from each other. And after test finished, both containers has been stopped. Also, as an example, we can make additional configuration by commands inside container. And
I think I missed it, but is it the test ran on the actual RAX40?
Yes, test has
What
been
was
run
the
on
test?
okay, I will show the list of tests that checking uname, call UCI, call top, check memory, and disk usage. That is
okay.
Simple commands like uname and
those are some built-in
from
tests. Yes, basically it has more, but it requires some entities to exist. For example, it requires some additional LAN device which will handle the as example.
This is great. Can you show the configuration files? Like we saw yesterday the UTF, and we want to see the similarities between the two.
I may suggest there is two options. Basically, wanted to show also how we have ported partially some of the basic tests from test photos by
yes, what this only
you're there now.
Oh, I see the AP configure new. This one is interesting.
Okay, configuration, test setup configuration. It's a JSON file. I saw the on printed message the piece of JSON that is case on which against which the shown test has been run. The same settings as I shown previously. And the second case, yes.
The devices section, that's not devices or tests or anything like that. So you have a test device called X42, and that test device has a number of other devices connected to it, CTT devices, so test infrastructure that can interact with it. And so the way it's configured now is that this X42, it has something connected on the WAN port and something connected on the LAN port. So those are the other devices that can interact with it. And in this case, they are Docker containers, but they could also be hardware devices.
Yes. Yes. The idea is that we described a number of devices presented in test setup besides main board tested, and we have a name for them and type. For example, Debian, Linux, and OpenWRT router, and so on. That has some abstraction class in board farm. And also we described how run that device prepare for test setup. So it may be not only Docker, but for example, Camel, virtual machine, or something real hardware. So for example, it's possible to add to devices list second Rex40 device, for example, and test will be able to manipulate, interconnect with several Rex40 devices, for example, if for test needed test purposes.
And some little addition, we may also basically we can add any device. So it may be a wireless sniffer. It can be some additional sniffer inside the network, like TCP dump. So basically, we can get the backhaul sniffer, fronthaul sniffer to mimic as close as possible the official test suite.
Okay. Example of a device was that Rex40 device with specific meta information about it, and some methods such check log, for example. The standard classes has yes, board farm devices, OpenWRT router. It has more methods that can, for example, get file via TFTP, and so on. Or, for example, maybe Linux. Linux, it's more common class. It allow to get interface IP address, MAC address, and so on. So it's do it by using UART, as you can see, and shell commands, but it's not a limitation. You can implement such methods using another ways. Okay. If you have a question, please interrupt me and ask.
I have one question.
Yes.
Does this the setup assumes the configuration is static, or does it also configure the devices as part of the I mean the mapping of the setups as part of the test?
For I see. I don't. I don't know. Strict question. Board farm has such abilities, as I see in code, that features, for example, so devices can be described more carefully. With listing the features or maybe some another meta information, and for example test can analyze current test setup description and decide can it run or not. Also, if it cannot run, it make skip exception, raise Python exception that said that this test should be skipped. Did I answer to your question?
Well, partially. My second part was, for example, you said that we have console access, to serial access to the devices. My question was, if there is some, let's say, for example, the IPs. So you have here configuration of IP per device, and this is something that I know that currently in the testing we have it static. So my question is if it's something that is also as part of the test, if we want to change the configuration and change the network configuration, if it's something that we can do, or is
you may do this.
I will answer the question if it's possible. So you can configure, you can use this board farm in order to configure devices. Okay, I can say you more, that actually you can think about config file that Python will open during the test, okay, according to, I don't know, for example, MAC address, and load the configuration file for specific device. You can do this for sure.
If question was about preparing setup for test conditions and then tear down after test finish to reset test setup to previous state, I did not investigate board farm for that, but I think it's should be one of its features. So it's responsibility of your code.
Okay, thank you.
Okay, one more question, so many questions. Okay, I will continue.
I have one more question.
Yes, yes.
Is the serial the only communication method that's provided by both farm?
No, serial console is just an example. One more standard method is SSH connection client.
So it has support to SSH. Good.
Yes.
So what we need to do to both farm is to extend and add another connection type, which will be copy, and then it will be.
I will show the copy sometime.
Okay, sorry.
Okay. And the second configuration, that example, when we have one Rex 40 and one gateway controller container. We could not run that container from board farm. Is it some troubles with running Python scripts of prplMesh from inside here? So we run the container permanently and just attach or detach that controller to the needed Docker network to configure to get connectivity between controller and tested Rex40 board. Okay, so we prepare container clear after, and that is how we attach to container shell. And for test, it looks like Debian machine. Okay, I will show how run tests, two tests adopt two prplMesh adopted tests, and then show the code and explain what happened. That is two tests, app config renew and reinit, append reinit. Cyan color is console of controller, and the white is Rax40. It should be fail. I didn't remove that to show you how fails looks like. So in this case, server replied with status error code not found, MAC address not found. Okay, about KP commands, now tests can run such KP commands, as you can see, for example, such, and we can see that the controller responds. That command, I will find one more, devset config, and the response running and complete. And one more is TLV sending. Okay, and about source code, it looks like yes. Initial app config is just checking log command implemented in Rax40 class, which check using grep the accepted regular expression against interested log, and the rest is more complicated. That's example how test can use devices descripted in test setup. For example, repeater one is board is main tested device, and the gateway is the second device in JSON. I could not receive it another way. Had no time for a good and official way. Okay, that is a workaround for container with controller to have connectivities with board. It's just such Docker behavior that on attaching to network, container received interface with new name, so we cannot hard code it. Okay, then okay, KP sending commands. We open socket to controller. Yes, this such way. Send example of sending a command, and another one. Okay, we saw the sending of that commands in output of TCP dump, and also sending in Rax40. The connectivity was quickly done via Docker network. I have added such IP address on Rex BRLAN interface inside. That's all for tests source codes. So tests has no knowledge is gateway or repeater real hardware or Docker containers, it works with them like with Linux machines, maybe with gateway that it thinks that its requirements that such device has listed on port 802. Okay. And yes, it's oh sorry, it's example of test suite configuration. It's a custom that I shown previously, and the rest was presented in board farm. That's all. Please ask question. I will try to answer.
One small note regarding the configuration. For tested configuration, there is a small feature which actually is just more kind of quality of life improvement. If you don't want to replicate some test suite, for example, in this case that you want to add some big test suite which actually includes test suite A, B, C, you may just to refer to them by using parentheses, as Ivan shows. In this example, it just basically refers to the self-test test suite, and all the changes is basically like a reference. So all the changes in self-test test suite will be here and will be reflected in any case, which is helps from code duplication. For the device itself, we may add, basically what you've seen, this is basically proof of concept, a very rough one. A lot of variables can be placed on the top in the config itself. According to the source code, you can check the debian.py in the devices folder. Almost any variable from this file can be used. So basically, you may, with one proper configuration.py, oh, not configuration, sorry. With one proper JSON file, you may actually reflect all required variables, and it's up to developer to actually use them or not. So you may set almost anything you want to. Multiple devices are possible in general. I did some experiments with loading all the devices at the same time, and board farm able to recognize if there is no device available. Bad thing, it's not able to queue them. So in case there is no devices, it basically says here, no device available, and exits with exit code. So it's have some kind of board management inside of it. In general, what we may also do here, we may also to add some TCP dumps to mimic the backhaul sniffer. We may add some real Wi-Fi scanner, and just by using TCP, just by making some of wireless device VLAN devices in RPI in monitor mode, and basically TCP dumping all the traffic to simulate the front hole sniffer, which will allow us to totally mimic the core components of official testbed using by single Raspberry Pi, and additional, like we will have two additional Wi-Fi to USB adapters in order to sniff all the traffic, or like one wireless adapter per tested RAX 40 or any other device in the test which is capable to run prplMesh agent. In general, transition may be done. It will require some effort as it's not totally compatible. But in general, from what I have seen, this seems to be like a good base for device abstraction, setup abstraction, which already works, and we just have to integrate into that if we will decide to use board farm at all. And it can be also easily adapted to almost any test setup. So basically, you have to just point the config file, JSON configuration file, to point it with the IPs, provide the required Docker files, or etc., and it will work. Dummy mode can be easily ported too, so we won't lose this functionality in case of transition to the board form. In general, what we want to hear from the audience, if it's worth to do some kind of second proof of concept or not. This is first question. Second question is if anyone has any more questions. Sounds weird, but as it is.
Concept, I don't think that it's necessary to go to a second proof of concept, because it's clear that we can do the things we need to do with this kind of setup. So I would go to deployment rather than a second proof of concept. Right.
Guys, I have some comment. I believe that it mostly better to use some existing framework that create everything from beginning. Especially if it's not main target of a specific community. Okay, but the question is if board farm, I don't know if somebody make a comparison with existing other tools that used in the because, for example, my personal what I don't like in board farm, and this is that every test you have to write code. Okay, and sometimes I would build, like object-oriented, to build some basic code, and I would like to create tests when I operate them existing blocks by a high-level language, much more easy than Python, for example. Okay, and such kind of framework can be found, and they exist. Okay, when you don't need to you don't need to create code for every test case. You can create blocks by code, and after this to build a much more complicated test cases in very easy way.
Well, Boris, we already discussed this on Slack, but basically I think that Python is already a fairly high-level language, and certainly you can write your test system in such a way that the individual tests are very easy to read and to replicate as well, to make. So I don't think that the fact that we use Python for our tests is such a big negative, especially since we already have a lot of developers and testers who know some Python. So I don't think that's really that big of a problem.
And there's another thing. The thing is that UTF is what we use in Intel, and it is based on both forms. It's not by chance that we wanted to evaluate both forms. We are using UTF in Intel, and I myself created a test which takes maybe 5 lines of code to test autoconfig renew, and autoconfig teardown in Python based on both forms. So I don't see a reason to use a proprietary language other than that is instead of using something generic that will also help our developers get familiar with something that will also help them in the future. This is one thing, and for the reason that in Intel we will only use both forms, and we want to utilize the same test as much as possible. So if the test is written in a similar fashion, then it will be easier. That's my
just
point
a
of
small
view.
note, you are still sharing.
No, I would like to show you example. I don't know who from you familiar with the robot framework, not tools that we exist, but the concept that when you write code in Python, and after this you can make very complicated scenarios by high-level language. I don't know. I will give you example. Okay, let's think that you want to replace image. How do you do this in the code? You need actually put every time code Python library that looks that FTP or TFTP.
Actually, firmware upgrade is not related to board farm. There will be a separate script, very simple. You don't need to do firmware upgrade all the time. But in order to deploy a new prpLMesh to the target, we are simply building the IPK again and using SCP and using standard OpenWRT DPKG to upgrade the prpLMesh. So this is.
Yeah. Okay, Tomer, if it's possible, I would like to show you 1 minute high-level language. Sure. Or if not, so we can stop this, but it's different approach.
I don't mind seeing a different approach. If we
you can see, so if you can 1 minute, I will show you, for example, I don't know, what do you want to show, Ivan?
For general tests from our source code.
Okay, it's good enough.
Okay.
It's good enough. This is how looks test. Okay, so you can see the high-level language that everything inside written in Python. Okay, the function written in Python, but you define statement in Python and write test in high-level language. Okay, so for example, if you go down, you can see the how we ping and how we acting the board. Okay, and we defined interfaces and so on. Ivan, can you go down to
what? Show another?
Yeah, so I don't know. This is, for example, us, we make pink, or I don't know.
It's more complicated. What I can show from projects, maybe. It's
one test that knows that the configure device, for example.
No, I didn't see at the test for a long time.
The different, the lazy one, pink or something like this.
Pink. Pink, it's the same as it.
Okay, so this is the test that we make in a different way. Okay, so you can see that it's written in high-level language. Now, under this, every statement is Python code. Okay, but after we write, for example, pink or something like this, we can reuse it in different test cases. Okay, Ivan, can you show one of the functions, send tag, for example, how it looks in the code? Now, this is the robot framework that allows the same things.
Saves and track.
Okay, so this is the actually the developer write the code in Python, okay, in options, and after this we can reuse it in this high-level language. So if you write send scapy packet, so it's, after this the comment is send scapy packet, something like this. But this is one of the options. Thanks, Ivan.
Okay, thanks for sharing. I think, and we will take it under consideration, but for now I think we should move on to Arnout's presentation. Because Arnout, I think you are going to present something as well.
Yeah. I have done a bit of design on the test flow stuff before Anton and Vlad started working on it. I have not yet adapted it to the learnings from the test flow, so this is fairly old stuff that I'm going to show, but it may still be relevant. Let me first repeat basically what Anton has already said. So what is the goal of test flows? Basically, the goal is to do integration tests. So it's not for unit tests; it's for integration tests, and it's actually not only for certification tests. It's for all integration tests should be there, at least the certification tests. So as Anton explained, currently we don't even cover the we only cover about half of the certification tests, so that should move to full coverage of the certification tests. But it should be a bit more. What is the difference with certification tests? Well, that is faster, basically. I'll go into a bit more detail of that later. It should also cover additional test cases, so things which are not covered by the certification tests, because in fact, the certification tests, they test a very limited subset of what you can do with multi-AP. In particular, they don't test any of the logic. For instance, once we have wireless backhaul, we will also we have a way to switch between wired and wireless backhaul when the wireless backhaul goes away. Or we will need some kind of management for that. Well, that stuff is not tested at all in certification, and we will want integration tests for those. So those are additional algorithms that we will want to test. And also we will want to test additional corner cases which are not covered by certification tests. For example, fragmentation is not tested by certification tests. There are almost no errors tested by certification tests. In the long run, we'll also want to test those. And then finally, we will want to run the same tests, not just in Docker, but also on platforms. As Ran, I think, observed, it would actually be better if you can test everything in Docker, because then you don't need any platforms and it's much easier to develop. We still want to also test on platforms, because then we also cover the BWL, which is a significant part of the overall software. And second, there are a few tests which are pretty difficult to cover sufficiently in dummy. For example, one particular example is onboarding, because for the onboarding, prplMesh itself is almost not involved. It's mostly the host APD that has to take care of that. So to really test that in Docker, we would have to pull in complete host APD into Docker as well, and that's a lot of additional work. So if we can also run tests on platforms, then we don't have to worry that we don't test that part in Docker. Let's swap these two slides. Now, the simplifications I mentioned, there are a few that we can think of. We don't have to do all, don't have to make all these simplifications, but these are some things that we can simplify to make things faster. One example is that the controller tests and the mount tests can be done at the same time. So at the same time, you test both the controller and the agent. even if the controller is running in Docker, since the control functionality is not dependent on BWL, you're still covering everything of the controller that way. A second simplification is that we're not going to do separate tests for 2.4 gigahertz and 5 gigahertz. So that basically divides the number of tests by 3. Also, probably we're not going to repeat most of the tests for wired and wireless backhaul. But again, this is we have to see to what extent we actually make these simplifications or not. Another possible simplification, but maybe we don't have to do that, is to avoid the sniffer. So the problem with the sniffer is that it's always going to be a bit unreliable because it's also going to capture other stuff that happens in the air. It's going to suffer from interference, and it's a lot slower. For example, in a lot of tests, the wireless sniffer is used to sniff beacons, to look at the beacon frames. That one is pretty reliable because the beacons are repeated very often. But of course, what we can simply do is query whether the VAP has been configured, which we can easily do. And once it's configured, since we don't care about host TPD, we assume that host TPD is working. We don't need to include that in our tests. And similarly, we can avoid the fixed time. So the certification tests are full of sleep for so long, sleep for so long. We can remove those sleeps by just polling and checking, the VAP is configured, now we can continue the test. And of course, with still a timeout of like 20 seconds or something. And a final simplification is that we don't need to reconfigure before each test. Although that has its limitations. So it means that either if there is a test that needs a particular configuration, we have to go back to the default configuration after the test, or we should still do reconfiguration for each test. Any questions or comments so far? No, this test flows approach is always going to have a number of limitations. So one limitation will be that we will do these tests only with prplMesh devices. So in the demo that Anton and Ivan have shown, you had two prplMesh devices. You had the controller and the agent. So the controller being in Docker and the agent being on Rex40. But there were no certified devices there. So there was no CTT controller, no CTT agent. So we still need the certification setup to be sure, does it work with an actual certified device as well? Now, once we've done that, and when we see that it behaves weird, we can adapt our tests, but we haven't done that up to now. So we really should do that. But we can adapt our tests to simulate or to check for some of the idiosyncrasies of those certified devices. For example, we could verify that no fragmentation is done of the M1 and M2 messages. So another limitation is that we test the agent and the controller at the same time, as I mentioned. That's one simplification to speed things up. This limitation has the advantage that we can actually use a single device running agent and controller and run a test on that single device. But it means because we do it at the same time, we also have a bit less certainty that way. My personal feeling is that it should be okay, but yeah, it's a divergence from the certification test. And then the overall coverage, even if we add more tests than the certification does, it will still be pretty or relatively limited. So we will, for the most part, only cover the happy paths, and we will not cover many error paths with those test flows. So if you want to cover error paths, we really have to make unit tests. The test flows are never going to cover all these corner cases. Questions or remarks so far? There is a more complete test setup that we will need to go to eventually. So instead of a single device under test, we will need in the setup several devices under test. So we have our 3 devices that we're going to target, and then of course Docker as well. The Docker will of course be running on the test device running the Python framework, so port farm in test flows. I've taken a NUC here, but it can just as well be a Raspberry Pi or a laptop or whatever. And there may be other test devices like a sniffer. I put G-Line here because it's a cheap device. Thinking more about it, actually the sniffer, it will need to have enough ports to be able to sniff all the devices at the same time. So G-Line is not going to be enough. So it may need to be a Torizomnia or something else which has many Ethernet ports. We could put a wireless station there. This could, of course, just be a USB device on the NUC itself or on the laptop or whatever. I've put it here as a separate device, but yeah, could be anything. We could also have an additional agent, although we could also just use one of the devices under test as the additional agent. So for instance, we could have a setup which has a Docker for controller, a Torizomnia as one agent, and the Rex40 as another agent. So the top here is definitely needed. I think we need an additional device to be a sniffer because we need to be able to sniff all ports. Yeah, do we have some device that controls everything? And this NUC or a laptop or Raspberry Pi will also run the GitLab agent. So that's the one that's going to connect to GitLab.
Arnout said you are going to skip the sniffing.
So yeah, that's the wireless sniffing. This is the wired sniffing we still want. So we still want to capture the 1905.1 packets and analyze them directly. So now we're using check logs to verify if a packet was sent. That's not a great way to verify that. So it's much better to instead use TCP dump. But the problem is if you put a switch between all these devices and this one sends a packet to this one, then you're not going to see it outside. So that's why we need the TCP dump to run on the switch itself.
Maybe use port mirroring of smart switches to to see all packets of devices on some special port connected to our controller machine.
That would be an option, but I'm not sure if you can easily mirror all ports to a single port.
It depends on switch, I think.
Yeah. Yes. What I used most recently, at least, did not have that. You could just mirror one port.
That's what's being done in the Wi-Fi Alliance testbed that we have. But yes, you need a special switch to be able to. Sorry?
In the Wi-Fi Alliance testbed, all ports are mirrored.
Yes, to one. Okay. Yes.
So then if that's easy, then we don't need that. Okay, then we don't need any additional devices. I'll adapt the slide. Okay.
Also, any free Wi-Fi enabled device which is capable or based on the Linux may be used as a sniffer to verify agents' behavior on wireless side.
Can you repeat that? I didn't quite understand.
If you have any devices which are free in setup right now, it's my wireless capable device. It can be used as a wireless sniffer.
So indeed, we can use that as the sniffer as well, as a wireless sniffer. But I was hoping that we should be able to avoid all the wireless sniffers. So if you look at how it's used in the testbed, it's not really very important, at least for the things that we want to test. And then finally, I'm going to show a design of how we can refactor the Python the test flows framework to match with this kind of concept and to be able to run test flows independent of the devices. Now, this has not been updated yet to include board farm, so it's a bit abstract. So the basic concept is that, first of all, now we basically have in the test flows explicitly, okay, there's a gateway, there's an agent, and there's a gateway, a repeater 1 and repeater 2, and we're going to explicitly send commands to those. The first step would be to make more abstraction of that and just have an abstract device, which could be a repeater or a gateway or any device, and then a process running on it, like the agent or the controller. And so the send copy command should actually be on the process, not on the device. You can then send copy commands to those processes. So you can send a copy command to the controller, a copy command to agent 1, agent 2, etc. And then you have the radios, which are available on a device, which is the configuration information you need to have a MAC address. And then, so these are all abstract classes. And then there are concrete implementations of those classes that should be configurable. So depending on your test setup, a specific instance of those classes will be created. And then those abstract classes, they have helper functions. For instance, on the radio, it would have a helper function. Assert has fab. The assert here is because I was assuming the unit test framework would be used, which has this kind of convention to do checks. So assert has fab. The Docker instance could just query the dummy BWL whether this particular VAP has been configured, and in the on an actual device it would check if that VAP is present in the host APD configuration. And I didn't mention the station, but yeah, for station it's the same thing. And the station would have so it's like a device, but not running prplMesh, and it would have things like associate and disassociate. And then you could have a dummy station which sends those dummy events to the file inside the Docker, and you could have an actual station, for instance, on an OpenWRT device that just starts WP supplicant. So all these devices have to be integrated in a test environment. So this test environment is basically what should be provided by board farm. So the thing that board farm would do is to based on the configuration file, create that test environment. And then we would add additional abstractions on top of that to have things which are useful for us. So this the station class, device class, etc. With those methods which are important for our tests, like send copy command. So the test environment is instantiated by port farm, and then we have the tests themselves. So the test will get the test environment as input, as an argument. It gets access to it. How that will happen, I'm not sure yet. Now, up to now, I assumed that this would be using the unit test framework. So then in the unit test framework, it looks like this. You have the, well, we would add an additional, the test case class is the basic entity of the unit test framework. We would have derive from that to have a flow test, which has this test environment as a parameter. And then you have several subclasses of that for the individual tests, which have then the test functions for the individual test functions. So this is a normal unit test approach. Yeah, how this will integrate with port farm, I'm not sure yet. So that's, I would like to use a unit test framework because I think it's this assert equals, etc. I think it's a useful abstraction. However, given that we do not have it now and that port farm doesn't have it either, probably it's just overhead to start adding it now. So I think that all this part we can just throw away, and we will just make the classes here and directly derive from, well, we probably will still want a flow test class, but that one would then derive from port farm and not from unit test. Any questions or remarks?
I have one note. Maybe it's possible to use such things as asset functions that such accepted result should be something. Yes, from unit test framework, but and other parts, such devices, the setup test environment may be used from port farm.
Yeah, I thought about that, but so indeed, assert functions, it would be it could be a way to still use unit tests, but on the other hand, since we have already a lot of tests and they're not using assert at the moment, I'm not sure if it adds a lot of value to start adding it now. What we could definitely do is to rewrite or rename the functions, the check functions, to assert something so that it's already in the same language as the unit test language. But that doesn't necessarily mean that we have to also use the unit test module. It's Python, so we can do duck typing. We just make it look like unit tests without actually being unit test.